chemistry class. After a long gap, so sorry for this type of scenario in our area. Now, today I will discuss a new chapter that is called electrochemistry. Electrochemistry. This is the branch of science or the chemistry which deals with study of interconversion of electrical energy into chemical energy and chemical energy into electrical energy. Chemical energy into electrical energy and electrical energy into chemical energy. This is the process or the phenomenon involved in this process in this chapter are many, but from very beginning, how electrical energy can be changed to chemical energy, first it is the matter of discussion. You know the term electrolyte. Depending on the nature of the matter, we can classify matter into three categories. One is conductor. Two categories. First, one is conductor, another is insulator. And insulators, conductors again divided into two types. One is metallic conductor, and another is electrolyte. So here, you know insulator which does not allow the electricity to pass through them. Electrolyte is different, but insulator is the substance which does not allow electricity to pass through it. That is, you may say rubber, plastic. These are some plastics. These are the insulators. Again, the conductor means which the matter which allows the flow of electricity is called conductor. So this conduct, depending on the nature, these are of two types. One is metallic conductor, another is electrolytic conductor. Metallic conductor is the metal, solid metal through which electricity can pass. Metallic conductor like copper, silver, aluminum, etc. that can allow electric current can flow from one point to another point. Again, electrolyte means the chemicals or the chemical substance which when dissolved in aqueous solution or in its molten state allows the electric current to pass through. As for example, solution of NaCl, sodium chloride, solution of NaCl or fused NaCl, etc. or any type. Electrolytic solution means in water. The solution in water. When NaCl dissolved in water, that solution can allow electric current or the electric current can flow to the solution. Again, fused NaCl or fused KCl can allow the electric current to pass through. Therefore, these are included in the electrolytic solution. The primary difference between these two is that the metallic conductor here, no substance flows from one point to another point. Here only electron flows from one metal atom to another metal atom. Again, in electrolytic solution, the positive or negative ion can able to go from one point to another point. So this is the electrolytic conduction, means the conducting power of the ions is to be considered. And second one difference is when temperature is increased, the metallic conduction decreases because of the electron flow is obstructed by the metal. Here, by increasing temperature, electrolytic conductivity decreases. But in case of electrolyte solution, with increase in temperature, more and more ions can be dissociated in the solution and the electrical conductivity becomes more. Now, I have to discuss a little more about the electrolytic solution. So let us consider this electrolytic solution which conduct the electricity can be studied by the help of electrolysis. First, I will switch over to the phenomena electrolysis. Electrolysis is the chemical decomposition of matter by the passage of electric current, by the help of electric current. Here we can say electrical energy is converted into chemical energy because electricity can able to drag the positive and negative in the solution, and there will be some chemical changes occur in the solution. We will discuss what are the chemical changes. So to study about the electrolytic conduction or the electrolysis, we have to consider a vessel, non-conducting vessel called voltmeter, or the electrolytic vessel, which it is a non-conducting one, in which two metal rods are dipped inside. Two metal rods are dipped inside, and the solution is one of the electrolyte. Solution electrolyte means here you may, let's say NaCl. Here is NaCl solution. NaCl is the electrolyte. So this electrolyte, NaCl, is a strong electrolyte. Again, if we consider the strong and weak electrolyte, we will discuss a little bit later. Now, these two metal rods are again connected to external circuit of electric current with the copper cap. External circuit to the electric source by the help of metal cap. So this is the wire, conducting wire, and this is the battery. And let's say here is the switch board. When this arrangement is known as voltmeter, here we have to discuss the electrolysis phenomena. What does it mean? Where this NaCl is kept in the solution, NaCl is broken down into Na plus and Cl minus in water. This is called cation and this is called anion. Similar way, in this solution, there are large number of Na plus and Cl minus are there. Na plus and Cl minus are there. When these two are connected, one side or the one electrode, this is called electrode metallic rod, and this electrode is connected to the positive part, so this is called positive electrode, or called, so to say, anode. And the negative part is connected to another metal plate, or called electrode, and this is called negative electrode or cathode. When this arrangement is given and switch is on, then what happens? This side, this metal plate or the anode becomes positive charge and cathode becomes negative charge. So this in the solution we have positive ion as well as negative ion. So by the attraction of the positive charge particle now tends to move towards this electrode, means towards cathode. Cation moves towards cathode. This is called cation. Moves towards cathode, and anion moves towards anode. This moves towards anode. What happens there? They now get a discharge at their respective electrode. What is the meaning of discharge? Here, when cation at cathode, what happens? At cathode, Na plus in aqueous solution, when reaches at cathode, Because of the negative charge electrode, it takes one electron and becomes a metal and gets deposited on this surface. Because of water again there, the sodium solid react with water, forming sodium hydroxide aqueous solution plus hydrogen gas. And here hydrogen gas tends to evolve at cathode compartment or at cathode. So this is the primary reaction at cathode. This is the primary change. This is also again called secondary change because sodium metal is unstable in water. Therefore, it undergoes secondary change to form sodium hydroxide as well as hydrogen gas. So hydrogen gas evolved at cathode. Now let us consider the chloride ion, and at anode, what happens there? Anode means anion, chloride ion goes towards anode. Because of the positive charge on the surface of the anode, it takes up the electron from chloride ion. It takes out electron from chloride ion, and an atomic chlorine is formed at cathode. This atomic chlorine, because of unstable, it again undergoes secondary change to give chlorine gas. So here what happens? Chlorine gas is evolved. So this is the chemical change. Here NaCl, in general, if you write in general, NaCl on electrolysis gives hydrogen gas in water and chlorine gas, as well as here becomes NaOH. Aqueous solution is there. So now the solution, NaCl solution, is initially neutral in nature. You know, NaCl is a neutral salt, so NaCl solution is neutral in nature, having pH 7. But after electrolysis, only NaOH remains, which is basic, and the pH becomes greater than 7. The pH of aqueous solution of NaCl after electrolysis increased, means it was 7 and after electrolysis becomes more than 7. So this is the phenomena. Here what happens? NaCl solid in water under electrolysis give hydrogen and chlorine. This chemical change needs some chemical energy. Where from that chemical energy obtained? From the electrical source. That means electrical energy converted into chemical energy. This type of setup is called electrolytic vessel or the voltmeter, and this is called electrolysis. And here we consider the NaCl is completely dissociated into Na plus Cl minus. Here we get hydrogen gas and chlorine gas at the respective electrodes. Now this discharge phenomena can be explained on the basis of their ability to get a discharge at the respective electrode, which is measured by the term of their discharge potential. It is said, lower the discharge potential of a cation or anion, easier is its discharge at the respective electrode. So this electrolysis is carried out in the aqueous solution. When it is taken in fused state, not in water, rather it is in the molten state, NaCl in the molten tarol avastha is in the molten state. Then what happens there? There is Na plus ion and Cl minus ion. And here Na plus and Cl minus in molten state, that Na plus get deposited at the cathode, no water is there, so sodium metal is deposited at the tips of the cathode, can be removed out, chlorine gas will be removed at the anode, no water is there. So this secondary reaction will not occur in absence of aqueous solution, rather in the pure state. But in aqueous solution, we are considering Na plus and Cl minus. There is another thing, we can consider the mutual discharge ability of the ions. In NaCl solution, we have Na plus Cl minus. If you go just little deeper, there is again also water. Water can be dissociated into H plus and OH minus ion. Now in the solution, not only Na plus, not only Cl minus, rather H plus and OH minus ion there. So there are two positive ions in the solution and there are two negative ions in the solution. Now, depending on their discharge potential, we can say between Na plus and H plus, the discharge potential is low for H plus ion, means very less. Therefore, when there is a competition takes place between H plus ion and Na plus ion, which will come faster towards the cathode. So let us now just think about the mutual discharge of the ions. Means in the solution we have Na plus and H plus ion. Between these two, H plus ion move faster towards cathode because of the low discharge potential. Because of the low discharge potential, H plus goes faster towards the cathode and get discharged as H plus electron and H atom, 2H atom again because of instability, they give hydrogen gas at cathode. Similarly, at anode, what happened? Towards anode, Cl minus as well as OH minus ion. Cl minus as well as OH minus ion. Both are negative ion. They both are trying to move towards the anode. But because of the lower discharge potential of Cl minus ion, that moves towards anode and they get discharged and gives out chlorine gas at the anode. The same manner, we can explain the different mutual displacement or mutual reduction, or so to say, they are discharge to low discharge potential phenomenon. Now, basing on the fact, the electrolytes we are considering electrolytes means the chemicals through which electric current can pass through in aqueous solution or in their molten state. So, in aqueous solution, when we are considering the electrolytic solution aqueous state, there are some electrolytes which are strong, and some are weak. Strong electrolyte and weak electrolyte. What are the strong electrolytes and what are the weak electrolytes? Electrolytes all are the ionic compounds because they can only give ions in solution. No non-ionic or the covalent compounds cannot. So strong electrolytes are those which can dissociate into 100%, nearly 100% in the solution. Let's say NaCl, HCl, H2SO4, NaOH. These are the strong acid and bases. Also completely ionizable salts. These are considered strong electrolytes. What about the weak electrolytes? The weak electrolytes cannot dissociate completely in the water. So they are, let's say, acetic acid or carbonic acid or any organic acids or bases. Acids or bases. They are feebly ionized. They cannot dissociate 100%. These are the strong electrolytes. They can dissociate into 100%, like an HCl in water can return as H plus and Cl minus. This is 100%. It's taken 100%. But in case of acetic acid, the dissociation of acetic acid, because of the weak electrolyte nature, they reversibly dissociate into acetate ion and H plus ion. Means the dissociation of acetate ion into H plus ion, again they recombine in that solution to give acetic acid again. So the dissociation is not at all 100%. And the dissociation constant, their degree of dissociation for strong electrolyte is 1. Alpha is equal to 1 degree of dissociation. But here alpha is less than 1. What is alpha? Alpha is the degree of dissociation. Means alpha is equal to degree of dissociation. Degree of dissociation is equal to number of electrolyte dissociated in water divided by total number of electrolyte added. Total number of electrolyte is added. This is the degree of dissociation. For weak electrolyte it is very less than 1, and for strong electrolyte is equal to 1. Nearly is equal to 1 or approximately equal to 1 for strong electrolyte. So this is about the preliminary concept of the electrolytic solution, electrolytes, conductor, insulator and metallic conductor, and again concept of electrolyte, strong and weak electrolyte, and how the electrolytic solution affected or the changed to chemical energy by the help of electric energy or electric current, that was discussed in the electrolysis phenomena. In this electrolysis phenomena, we will again discuss what are the applications of the electrolysis in day-to-day life. We will discuss in next class. Thank you.